Today we're pushing the Quest 3 to the next level for graphics and performance, and it's incredibly simple to achieve results like the ones you're seeing on screen right now. I'll show you the easiest way to unlock that extra headroom, the 3 settings that make the biggest difference, how to check you haven't pushed things too far, as well as a completely free route if you don't want to buy anything. Now my recommended option is Quest Games Optimizer, and I'm sure you've likely heard of it before. It applies hand-tested settings for each game automatically, and its newer sharpening tools can create a surprisingly big clarity upgrade without relying on a massive resolution increase. The current version of QGO is 14.3.0. It's only $10 and it supports Quest 3 and 3S. You can get it from the official itch page linked below, then follow QGO's current headset installation guide, and the setup is actually now much easier than it used to be because it no longer requires developer mode. Once it's installed, open QGO, find your game and look for a tested profile. Depending on the title, you may see HD, HD+, performance or battery saving options. Pick the result you actually want, launch the game, and you'll already see a big improvement. But we're gonna take it even further. The main reason I recommend QGO is exactly this simplicity, but as promised, I'll show you a free option later as well. Now the first setting I'd try is sharpening. QGO's latest version added 2 options for this: MetaQuest Super Resolution and Fidelity FX CAS. Both work alongside the normal game profiles, but they're off by default, and you can toggle them while the game is running to compare the results on the fly. I'm zooming way in here to make the difference clearer after YouTube's compression, but these changes are extremely visible with the naked eye while in the headset. So which sharpening option should you pick? Well, MetaQuest Super Resolution is the smoother, more natural looking option, so that's my starting point. Fidelity FX CAS is stronger and adds more edge contrast, which can look fantastic in a softer game, but it's also way easier to overdo. Sharpening obviously doesn't create extra geometry in the game, of course, but it can make the image look much clearer without the heavy cost of a giant resolution increase. It still isn't free performance though. The exact GPU cost depends on the scene, but this is now one of the best first upgrades because the visual return can be much bigger than the performance hit. Turn it on, look at the comparison, and only keep the stronger option if the image still looks natural. This extra clarity matters most in games packed with small details, which makes Puzzles of the World a perfect example, and they're kindly sponsoring this video. It's a relaxing tabletop puzzler from Astral Shores Games for Quest 3 and 3S, where you assemble detailed wooden miniatures while surrounded by stylized destinations from around the world. You can use hand tracking or touch controllers to pick up each piece and start snapping the objects together. It combines satisfying building mechanics, immersive environments, a great soundtrack, and a cozy atmosphere. And the game currently features 8 puzzles and destinations, including Kyoto, Venice, Paris, Machu Picchu, and others, with even more locations and puzzles coming soon. And once you complete one of the puzzles, you will unlock the night version of that environment. The small pieces, layered architecture, and distant scenery make resolution and sharpening easy to judge and the perfect testing ground, though the game already looks great even without tweaking anything. Puzzles of the World is available now on the MetaQuest store, currently rated 4.7 out of 5, so check it out at the link below and get a 10% discount as well. Thanks to Astral Shores Games for sponsoring this section of the video. Now for the setting with the biggest raw clarity potential: resolution. Raising the game's render resolution gives the headset more real image information to work with, so fine detail and distant objects look cleaner. It's also usually the fastest way to burn through your GPU's headroom. This is why the tested HD or HD+ profile should be your baseline. Don't copy one giant number across your entire library. A slow puzzle game, a physics-heavy action game, and a title already pushing Quest 3 hard won't have the same budget, but all of them can benefit. If you want to go beyond the tested profile, increase the rendering scale in small steps. Then launch the same repeatable scene and watch performance. The moment the game stops holding its target frame rate, you've probably found the limit. So drop back one step, because more resolution is only an upgrade while the game remains stable. The Quest 3 and the Quest 3S support 72, 80, 90, and 120 Hz, but with QGO you can actually fine-tune that with way more granularity. Higher refresh can make the motion feel smoother, but the game has to produce more frames every second. Just as a reference, 90 Hz requires 25% more frames than 72, and 120 is a much bigger ask again. For slower games, 72 or 80 Hz can be a smart trade if it gives you enough headroom for a noticeably sharper image. Fast action, rhythm games, or anything with rapid head movement may feel better at 90 or 120. There isn't one correct value here. Choose the experience first, then spend the remaining performance budget on resolution. QGO also exposes CPU and GPU performance levels. Broadly, the CPU handles game logic, simulation, and draw call work, while the GPU does most of the rendering. Raising the level of any of these can help when part of the system is genuinely the bottleneck, but maxing both out for every game is a bad default. It increases power use and heat, and the headset can't throttle when it runs out of thermal headroom. Use the tested profile first. Only change CPU or GPU levels when the performance overlay shows a problem you're actually trying to solve. Then there's fixed foveated rendering, or FFR. The Quest doesn't have eye tracking, so unfortunately we can't use dynamic foveated rendering. But FFR can save performance by rendering the outside perimeter of the image at lower detail while keeping the center sharper. A higher FFR level can recover useful GPU headroom, but the transition can become visible in your peripheral vision. A lower level looks cleaner but costs more. It's a trade-off, not a quality slider where higher automatically means better. So the easiest workflow is simple. Start with QGO's tested profile, add whichever sharpening option you prefer, and only then push resolution further. Change one thing at a time, and if the game stops holding its target frame rate, undo the last change. To make sure the result is stable, enable the OVR metrics tool overlay from QGO. You can also download this separately from the Meta Quest store if you're not using QGO. You don't need a full benchmark. Just watch the application frame rate in a demanding part of the game. If you selected 90 Hz and the game can't stay near 90 frames per second, or you see repeated stale frames or stutter, you've probably pushed too far. Lower the resolution first, reconsider the refresh rate target if that makes sense, or return to the tested profile. Now, if you don't want to buy QGO, you can make many of the same global changes for free with SideQuest. Once the SideQuest VR app is installed on the headset, its advanced settings interface can change the render resolution, refresh rate, CPU and GPU levels, and fixed foveated rendering directly inside the Quest. You don't need to reconnect it to a PC every time. Now, for the initial SideQuest setup, you do still need developer mode and another device, a PC, a Chromebook, or a compatible Android phone. But once the SideQuest app is installed, you can change all of these settings directly inside the headset. These SideQuest controls are essentially a friendly interface for temporary ADB overrides. They're useful if you want one global change, but they aren't tested per game profiles. And games can actually override some of these values, plus the settings reset after a full reboot. If you prefer the fully manual method, raw ADB commands can set the same Quest system properties. Texture width and height control the render target, refresh rate accepts 72, 80, 90 or 120 on Quest 3, and there are separate properties for CPU level, GPU level, and foveated rendering. I've put the exact current commands and the rollback for everyone on screen. The safest universal reset is just simply rebooting the headset, because Meta's debug properties don't persist across a reboot. Just don't paste a maximum value command from an old Quest 2 guide and assume it's an upgrade. This free route works, but it's global, manual, and easier to push into unstable territory. QGO is what turns the same basic controls into automatic per-game tuning, adds the new sharpening options, and gives you tested starting points with straightforward rollback. So yeah, the Quest 3 and 3S often leave visible headroom on the table, and QGO is still the easiest and best overall way to use it. Start with the tested profile, turn on Meta Quest Super Resolution, and treat resolution as the big expensive upgrade. That combination delivers most of the benefit without turning every game into a science project. Use SideQuest or ADB if you want a free alternative, use QGO if you want the result to follow each game automatically. If this helped your Quest look better, subscribe for more straight-to-the-point VR guides and let me know which game gave you the biggest improvement. Now consider checking out this video next, and I'll catch you soon. Cheers, guys.
That's fewer.